I think I've got this one figured out, but I'm going to send it to you anyway in case you have some additional input for this. But I like to give the students some kind of fun examples that they can experiment with, and so this is one of those examples. And in this case, this disk only has a single mate constraint between the back of the disk and this face, and then go to the dynamic simulation environment in Inventor. And so rather than do a 3D contact, with this is at a little bit of an angle with gravity defined, rather than doing a 3D contact, which can be really intensive to compute, use 2D contact. So the single constraint was converted to what Inventor calls a planar joint, where that back plane of that disk has to stay on the plane of this part as expected. And then 2D contacts between each of these pins and the disk, and then imagine a boundary or a fence going around this inside here, and that fence, Inventor sees that as going to infinity. Think of that as like we extruded that boundary, as a perpendicular extrusion, both directions to infinity. So Inventor sees that as a boundary fence, which I can either tell it to stay inside of the boundary or stay outside of the boundary. And so I think I figured out how to do that in SolidWorks. So I'll go to SolidWorks. Well, actually, let me just play this. I mean, it's going to... Now, the first time through, it's going to be slow depending on the number of calculations. So right now I'm doing 475 calculations in 2.5 seconds. But the mechanism acts like you would expect it to. And also, on each of these 2D contacts, I also set the resistivity. So if I go to the properties, I have the restitution, I have it set to 0.4, and I have a friction value put in here. And so let's go to SolidWorks. And so I've set up something similar in SolidWorks. And so what I've done is I've gone around this gray line is my boundary sketch, the fence, that I want to keep that within that fence. And so I did a curve contact, and then I have the single coincident mate between the back of the puck and this face. And so I put in that I've done 2 pins. So I've done the first pin and the disc, and then I've also done the outside boundary, and set that to the inside direction. And so then I have to go through and do each one of these. And so I would go through and do another one, and so I'll put it on the curves, and I'll again select the curve on the disc, and then select the curve here. So this is the same way that I would do this portion of it in Inventor, and go through. Now it's a little bit tedious, and it's tedious in Inventor as well, to go through and do each one of these 2D contacts. And so I'm not sure if you have a simplified technique for doing those that you might want to demonstrate. And let's just do a couple more, and then I'm gonna get tired of doing this. But anyways, it is something that would have to be done. Now I tried doing the solid body contact, and that just locked up SolidWorks when I gave that a try. I'm not sure if there's some tips on that you might have. And I set the number of frames per second at 120, and left everything else the way it was. So let me play it one more time and uh, see how it goes. So actually it just fell right through that one. It did come down here though, and worked okay down here. I thought I had set this one. Let me rewind that. Go back up here. So I'll calculate. So it hits this one, and then it just went right through that one. Let's increase the frame rate on this. So I'll put this up to 240. Now I'm not sure the effects down here with with that 3D contact resolution. Actually, let's turn on this precise contact, and I'll play it again. I'll rewind this. I'll do a calculation. Hits the first one, went right through the second one again. Yeah, we get this one working. This one will be, this one is a really fun one for the students. I actually had the freshman students come in and do this the first day, just for a fun exercise.